Last week, I did a stream where I started to rewrite a CLI that I had written in Go previously, about a year ago, actually, in Zig. And I ran into some issues, and maybe it wasn't a great day for me to stream, but one of the things that I got caught up on was the new reader and writer interfaces. This project uses them a little more heavily than some of the other stuff that I've worked on. And, there were quite a few changes. So I finished that, I think, and there might be a couple more refactorings to do. But I wanted to walk you through the differences between these two pieces of code, these two code bases, really, because there is a lot that I learned in the process, and I think it's really cool to show off some of the things that Zig does super well compared to Go's more simplistic equivalent. And again, I say simplistic intentionally. Go tries to be very simple, and I don't necessarily think it's bad, but this is one of the type of things that I'm going to show you that feels so much better in Zig, in my opinion, than Go, even though the Go implementation is totally valid and fine too. Okay, so I have a pull request up on my screen. I'm not sure if the best way to walk through this would be through a pull request, so we're going to try that. But if you want to follow along, github.com/Brad Seipert, that's CYPERT/book/pull/8. So start on Zig, rewrite 0.15.1. It'll probably be merged in by the time this video is published, but we'll see. Okay, so let's just talk through the Go code first, because I think it's important to understand where we started from and then where we have ended up. So what might actually be better is if I pull up each of these files via the view menu. So I'm going to do that. So we'll pull up this. Did it pull it up? It did. Okay. This one and storage test. Outside of that, and browser.go. Sorry, I forgot about that one. Okay, so really the project itself is quite simple, at least in the Go implementation it was, in the Zig implementation it's not too complex either. There's 5 files from the Go side. So our main file looks something like this. We have some imports, we have our main package. I'm gonna assume that if you're watching this, you're probably able to read Go and understand what's going on and maybe have some familiarity with Zig. So I will gloss over some of the fundamentals. But we're creating a structured logger, which in the Zig version, we don't really do a structured logging. It doesn't really seem relevant. So we canned that. But we have this struct that is essentially an input, right? And what we're building is a CLI. So I thought about using Cobra in the Go space. I thought about using Clap in the Zig space. And what I found is honestly, I wanted to try to see how it would come out if I built it myself without pulling in a dependency for that. Okay, so the struct takes in an input. That input has a bookmark. It maybe has a path. It maybe has tags. It maybe has a search flag, maybe has a delete all flag, maybe has a delete flag, maybe has a list flag. And then there's this extra I am sure Boolean that I was using to indicate that you're aware of what you're running and don't need confirmation. So if you want to delete all and skip the confirmation, you could pass the I am sure Boolean in. And that flag is different. You'll see that in a minute. I don't know of a much better way to solve this in Go outside of having multiple structs and doing like an any cast and then casting out the piece that you think it would be, and safely checking that, or doing something with reflect. Like, it doesn't feel great. So this is something that I'm actually really happy with in the Zig version, and we'll get to that in a minute. Our main actually looks a lot cleaner in the Go version. I'll be transparent about that. But we parse our flags, and then we check if it is a certain type. So if it's delete all, then we handle delete all. List, we handle list. Delete, we handle delete. Bookmark, we handle, specifically making sure that the bookmark is not equal to an empty string. So you have to provide a bookmark. Otherwise, we handle open. And actually, this is kind of interesting. If the bookmark is not an empty, if it is an empty string and you pass in a delete, we have a bug here where it tries to run open. So that should be fixed in the Zig version too. There are these little handler functions that essentially do like our basic standard out IO type stuff and scanning and making sure that you're agreeing to the thing that you want to do, transforming your input, and then actually doing things like delete bookmark file. Handle delete, so you can see here we get our bookmark file for append and read write, and then we delete a bookmark. So we proxy out to this storage.go file, which we'll get to in just a minute. Store is the same thing. Handle list, more or less the same thing. So we actually call search bookmarks with an empty search, so everything will match. And then I create a table using this table package that we just hand roll in Zig instead. Search is exactly what you saw above, except we actually pass in the bookmark that you want to search for. Handle open, we call get bookmark, and then we open external. This open external comes from our browser, which we'll look at in just a second because it's really straightforward. And then our flag parsing logic here in Go is actually really nice and simple. The Zig version is a little more complex. So that's our main method. What might be good is actually if we compare them one at a time, side by side. So if I pull up main.zig, and we'll open this in its own file here, and we'll just move that over. So what does this look like in Zig, right? Some basic imports, destructuring out the bookmark into its own const here just to make it easier to access. We have input actions. So these are the actions that you can take. You can store, open, search, delete all, list. Those are your options. And then we use these tagged unions here. So I'm using the union keyword with an enum to create essentially a tagged union. And what this is doing is saying, so when you have a union, only one of these fields can be active. And since we're using the enum as a type for that union here, we're creating what is called a tagged enum. A tagged union, I should say. And the only one of these can be active, just like a union, but these, the properties here are enum values. And what that means is we can switch on them, which you'll see down below, and it turns out pretty clean in my opinion. I have standard out, standard in, and standard error that I access all throughout this file. All of that is handled in main.zig, so the paths, the browser, the other stuff shouldn't access that, and if it does, I need to refactor away from that. So I am just newing up these globals here. Maybe not the best solution, but I found that I was repeating so many lines of code all over the place, and I thought maybe we'll just pull them out to globals and see how this turns out, and so far it's turned out pretty great. We have some more not necessarily boilerplate, but boilerplate compared to Go. So Go is going to be garbage collected, so we don't have to worry about manually allocating things and managing those allocations and deallocating them. So you're going to just see more of that in the Zig version. That's what we've signed up for. There's some of it here. We have a similar experience where we call parse args. We have to pass in an allocator so we can do some allocation for those parsings. And then I believe that actually cleans up after itself too, but I could be wrong on that. No, it does not. We clean up after ourselves down here. So yeah, we try to parse those args. We have a defer block where we deallocate the tags that we have parsed from the input if we find those. And then we switch on that input, right? So we have a couple things going on here. We look if it's a store type, and if it's a store, we destructure out the struct up here. So that's what this would be in this case. And then we call handle store, and we pass in an allocator, and we pass in that struct, that S. This pattern is repeated all throughout the rest of these. So opens the same thing, handle open, search, same thing, handle search, delete, same thing, handle delete, and so on and so forth. The meat and potatoes of the dispatch logic is down here. It's really not too different. In fact, I think if you were to compare the Go code to the Zig code, you'd find that it's basically the same thing with just a little bit more explicitness in the Zig version, specifically saying like, hey, we're taking 10 bytes here. We have to make sure that we're doing our flushing. We are using, standard mem to do string type things that are a little easier to do in Go. Same with handle delete. Worth mentioning here, one of the paths that we take in this approach is we get our bookmark file, and then we are essentially turning that into a reader right here. So we are reading, and then we have an allocating writer, and then we pass in the reader and the writer to our bookmark delete method. The ordering of this parameters feels a little weird, so maybe I should change that and fix that, but maybe something I can do after this. And then we write to a file. So what this does, this might look a little weird, but the way that this essentially works is we stream the contents of the reader into this allocating writer. And if we find a match that we want to delete, we just don't stream that line. The whole thing is stored as a CSV. Probably should have mentioned that at the very beginning, which gives you the ability to easily customize your bookmarks in your spreadsheet operator software of choice. If you'd like to do that type of stuff, you can. It also makes it easier to share. So yeah, just default CSV. Okay, so yeah, we have that. What's interesting about this too is I bet if I took another crack at this, I could probably skip this allocating writer. And I actually would like to, so maybe that's something I will try to do after this as well. But we should be able to just write directly to the file using a writer for wrapping the file instead of this like allocating writer that we have here, which would be great. Fewer allocations is always a goal. One thing I didn't talk about that I maybe should, all of these have an input that is the struct that's defined in that tagged union. I don't know of a better way to get the actual type safety here. So what I ended up doing was, this is really strange, really, but a type of cast on an as with input undefined, and then I grab the delete property off of that, or the delete enum value off of that. So yeah, there might be a better way to do this. I need to figure that out too, but this works and it's type safe, and it works for me. Okay, same thing with handle store. Very, very similar. We get the bookmark file. We get a writer for it. Noticing that we're getting append values here, not append values. We are setting the append flag on the bookmark file here, and we are turning that into a writer and then passing that into store bookmark. So we create a bookmark like so, and then we call store bookmark on it, and we give it a writer that we want to write to. This is really nice, and you'll see this when we get to our tests, because I was able to just wrap basic buffers and writers, and then I don't have to worry about file I/O or anything like that in tests. And Go does very similar stuff with Go's I/O packages as well. So not necessarily something that we get from one over the other, but something that I embraced a lot more when building the Zig version. Handle list is more or less of the same. You can see we call search. We have to do some deallocations here at the end, and then we try to print that table. Print table is just a helper that prints the table for us. Search is very similar to list. Open is pretty similar. The only thing that is really different between open and everything else up to this point is that we call browser.openExternal, which we will get to in just a minute. And then we have our print table. There's some logic here if you want to look at that. It's really just formatting for standard out, so nothing particularly interesting in my opinion, but feel free to pause the video and take a look, or open the PR yourself and take a look. Okay, parse args. Yeah, this is where it gets a little different. So we are calling standard process args with allocator, so we're allocating space for these args. We're skipping the program name, and then we're creating a tag list and deinitializing that at the end. That tag list is going to store the tags that are provided. And then we have our positional args, so things that will essentially process these like so, and determine if it is search, if it is delete all, if it is delete, if it's list, and if the I am sure flag was provided. There's probably a better way to do this, but this works, and it works fairly well, and in my opinion, it's fairly easy to read. This one right down here is us essentially building the appropriate input tagged union based off of what the user typed in. So if it is a delete all, then we create a delete all input, and we provide the I am sure flag if it's provided. Yeah, that's the gist of it. There's this little trick that I found too that is essentially if you run zig build test and you aren't seeing the tests from all of your other files because you haven't connected them through your build.zig, you can do this and it will test all of your public tests. So if you have a test at the public scope level, it will go ahead and run all of those for you too, which is really nice. Okay, paths.go is essentially just getting some paths for us using the user config directory. This is the Go version, of course, and then joining some path stuff. This is used for getting the bookmark file path, where we also call paths.join bookmarks.csv. There's a little helper here to delete that file. There's a little helper here to get that file, creating it if it needs to be created. The Zig version is quite similar. So paths.zig. That's actually quite a bit longer too, worth mentioning. I have an enum here for file modes. In hindsight, I probably don't need these, and I probably could have just used what was created or what exists in the standard library. But I was kind of trying to copy things over one for one and refactoring from there. So maybe that's another thing worth cleaning up. Storage path, there you go. Get app data directory, and then the sub path that we want. Get bookmark file path uses storage path, does some path joining. You'll see that all over the place. Delete bookmark file path, exactly what you'd expect. It's worth mentioning that standard FS current working directory gets you a directory, and directories can handle relative paths, which is nice. If you were to do things without looking up a directory first, my understanding is that relative paths maybe don't work as you would expect. So this approach seems to be, I mean, it works, so it definitely seems to work. Bookmark file path, kind of what you would expect here, we call, or sorry, get bookmark file, kind of what you would expect here, we call get bookmark file path, we get the storage path, we create the directory if it doesn't exist, we check if the file exists, if it doesn't exist, we create it, and then we switch on the mode that was provided. Like I mentioned, I have that enum here up at the top. All of these map one-to-one to a different type, except for this append read write. So, and append and being write only. So I have my enum values, but I probably could have just been using the ones from the FS package. Okay, some tests. So like I mentioned, actually these are the path tests. These are not the ones I was referring to. But there's a little bit of file system tests here that maybe should be stubbed out in some way, shape, or form, but for now it works. Okay, so that covers our main.go, our main.zig, paths.go, paths.zig. So we have storage.go. This is where the meat and potatoes of the bookmark storing works. So package main, some buff.io, some other imports. We have a bookmark struct here. We have this store bookmark method that all it does is it takes in that writer and writes the CSV values. Worth mentioning, there's a breaking change here because if I'm writing this tag slice in Go, what I end up getting is, what would be the easiest way to do this? Maybe just pull up a terminal really quick. So that would be something like github.com/ and then the tags are written like this, which is not, A, B, C, something like that, which is not what I want, and not really valid CSV. I guess it sort of kind of is because CSV is pretty loose, but I would rather them just be comma separated. All of the CSVs after the bookmark and the path are tags. So a random breaking change between the two because I fixed that in the Zig version. Delete bookmark over here. We are getting the bookmark file path, essentially trying to take the same approach here. We're using a scanner. We're reading in the reader that we pass in. We create a bytes buffer. We check to see if it has that prefix. So that prefix being the bookmark you provided with a comma to make sure that it is actually valid. There's some sanitizing that maybe should take place here because if somehow you manage to get an extra comma in there in your bookmark name, we could run into a scenario where we end up breaking things or deleting things in a way that doesn't really make sense. I don't know how realistic that is, and I am not super future-proofing this at this point since that's, to my knowledge, I'm the only one actually using this. But we'll see. I have big plans for this project, so maybe more people will end up using it in the future. So we do that writing, and then we call write file here at the end. So we're writing that file back to the file system. Okay, search bookmarks, kind of what you'd expect. We have a scanner just like before. We do some strings containing to see if it exists. There's our query. We do some formatting. And then we essentially build the bookmarks based off of that. And then get bookmark is pretty similar. We create our scanner, we scan each line, and then we check to see if the string prefix has the bookmark that we have provided. Then we build that bookmark and we return that. So there's some of it there. The Zig version is quite a bit bigger. So that was storage. So let's pull up storage and let's take a look at it. It's worth mentioning too that when I've done Go to Zig comparisons, most of the time they're actually pretty similar line for line. And even in some cases, I've had fewer lines of Zig code than Go code, which feels a little weird. This project has been mostly the opposite. And I think part of that is that the new reader and writer interfaces are just so explicit. And yeah. Okay, so standard imports. We have our bookmark struct, we have an init method, and then I actually kind of changed the API here a little bit, and I added these methods on the struct. So I've got the bookmark struct, and once you have a bookmark, you can call store bookmark. The way that it works, very, very similar. You take in a writer that you want to write to. We do the printing of the value and the path, so like gh and github.com. And then we iterate through all the tags and write all the tags. Worth mentioning, and like this is very reasonable, so it's kind of weird to even call it out, no allocations. So really nice, despite doing input formatting and things like that, we're doing it all via the writer and the print method on the writer, so we don't have to actually allocate memory to like massage strings to fit the format we would want them to, and then write it and then deallocate that memory. No need for any of that. Delete bookmark. I'm like weirdly proud of this. I don't know if this is the best solution at all, but I'm really happy with how this turned out. So essentially what we're doing is we have that bookmark, we have a writer and a reader. And what we're doing is we are essentially using peek on the reader to peek the value's length. So that value being the bookmark, so GH in this case, 2 characters. What we're doing is essentially we're checking to see if the peeked value, so like in the case of self.value.length being GH, this would be 2, so we peek the first 2, and then we check to see if that is not equal to the value, so GH again in this example, and then if that is the case, we stream until we hit a delimiter, which is a new line. So we're streaming as we go, and then we stream the remaining bits of the writer. So essentially, you know, as long as we are, the line we're looking at does not start with this value, then stream it to the writer. Okay, cool. So, and then we have a lookup here. So lookup is essentially, it's going to be a loop, and we are taking delimiter exclusive. So we're taking a delimiter, excluding that delimiter. So we're taking up to our line break. And then we have a couple different error cases that we need to handle. Specifically, the stream too long one is kind of interesting. If you find yourself in a spot where like the value is too big to fit into a buffer. So let's say you create a buffer of like 8, and you end up reading, like the line break is 20 spaces in. It's not going to fit into that buffer, so you're going to get a stream too long error. So I'm capturing that and returning a not found. I don't know how realistic that is. If that is an issue that someone runs into using it, file a bug report and we'll fix the sizing of the buffer, or maybe find a better way to handle this. But yeah. We use split scaler to generate an iterator, and then we get the first value. We check the first value if it's equal to the value. We grab the path using iter.next, or else we return invalid format because it is an invalid format. And then we collect the remaining fields as tags, and then we return that struct. Kind of a lot going on there. Search is kind of similar. So we create an array list of bookmarks, set it to empty. We have an error defer where we clean up after ourselves. We use a while loop here, and then we do more or less the same thing, but instead of returning early when we find something, we append those results. And then at the very end, we call results.toOutSlice, pass in our allocator, and return back a slice of our results. Delete a bookmark, kind of the same thing as before, sort of, but a little different. So we're taking delimiter exclusive, and then we are checking the prefix, and then we are essentially trying to do a little bit of manipulation here to determine whether you should or should not write the line. So if it is not the thing you're looking for, keep it, write it back out. Otherwise, we skip it. Kind of worth mentioning, this was the original implementation, and then I decided to come up here and create this delete bookmark function. So yeah, I have 2 ways to delete a bookmark, so maybe I should clean that up. The tests here are really cool. So this is the part that I was excited to show you. One of the parts that I was excited to show you, rather. So I've got a test for storing a bookmark, and the part that's really cool about this is like this project uses the file system pretty heavily, but I don't want my tests to do that, with maybe one exception over here being the paths piece. What I would rather do is be able to just make sure that things are being output in the format that we expect them to. And since the storage.zig file is not actually aware of the file system at all, it just knows that it's working with readers and writers, our tests become really clean too. So we have a bookmark here. We're initializing the GH GitHub one that I've mentioned several times. I've added a couple tags here. And then I have a buffer that I'm using for standard IO writer right here. And I'm using a fixed buffer, so we're passing that buffer in here. And then I'm passing that writer in to store bookmark. And then finally, we flush, because don't forget to flush. Finally, we call testing expect equal strings. Here's our CSV value that we would expect. And then we call .buffered on that writer to get that full string value. Lookup's pretty similar, kind of doing the same thing here. So we call lookup, again, fixed reader. We pass that reader in for lookup. We want to look up GH. We defer freeing those tags because that's something that we have to do to clean up after ourselves. And then expecting that these match the things that we would expect them to. Test for search bookmarks all. I could go through these. I would recommend, if you're interested in this, pull up the PR and look through them. But I don't want to take too much more time up for that. We had similar ideas, similar ambitions for tests with Go. So here's a test. So we have a bookmark called Goog, and then it points to google.com. It uses search and common, and then we have GitHub here. Yeah, so we were searching for, well, nothing in this case. We were making sure that none of these came back. So maybe I should add a similar test to our Zig version just to make sure. But yeah. Finally, and maybe the most interesting piece, just because it's a little different than what you might expect, is the browser piece. So originally this was going to just be web browser, but we ended up changing, I ended up changing this to try to open file system paths as well, if it made sense. So here's the Go version. Short and sweet, as we use a regex here. We check to see if it starts with HTTPS. If it does, we use that down here for Windows specifically, because we need to pass that to run DLL32 and say that, hey, this is a file protocol handler, and it's specifically url.dll. And if that's not the case, then we just give it to Explorer and we call the select command on it and then pass in the path. So we say, hey, Explorer, open this up. Mac's really straightforward. We just call open. Linux is really straightforward. XDG open, same thing. So you can kind of see what that looks like. The Zig version, quite similar. I think it's cleaner. And worth mentioning, I've said I think it's cleaner or something similar several times. Perfect Go code and perfect Zig code side by side. I have no idea which is going to be cleaner. But I have spent more time on the Zig version, which also makes me think that that might have something to do with it being cleaner as well. I'm not trying to say that Zig's cleaner than Go or Go's cleaner than Zig. I'm sure both are very, very legible when someone actually takes the time to really sit down and write them properly. I'm trying to do more of both, but as someone who's full-time employed, finding time to work on personal projects is always hard, and I tend to favor working software over perfect software. Okay, with all that said, OpenExternal and Zig looks really similar. We switch off the built-in tag for the OS. We check if it's Linux. We call standard process child run, and then you can see we're calling XDG open, just like before. We're not using a regex here. Found that it would be simpler just to check if it starts with this. So if it starts with HTTP or starts with HTTPS, then it is a URL. And if it is a URL, we call standard process child run DLL32. We pass in the same stuff. Else, Explorer, select, pass in the same stuff. On Mac, we call open and we pass in the path just like before. We clean up after ourselves, and then we have a little bit of a test here just to make sure that things are working like we would expect them to. That's really it. That's the whole rewrite. Outside of me changing my gitignore to add the Zig cache and adding build.zig and build.zig.zon. These are straight out of the box, no dependencies or anything, so there's really nothing going on there that is worth talking about. I think that covers it. The plan is to merge this in, and book will be in Zig going forward, so it should be a much smaller binary and something that, to be honest, I'm a little more excited to work on. Go is great. It just doesn't really excite me as much anymore. The next plan for this is to add a terminal UI, a TUI. So look forward to that sometime in the near future. I think that's it. If you haven't yet subscribed to the channel, I'd love for you to be around for future videos. I enjoy talking with every single one of you. So please let me know in the comments below what your thoughts are on maybe a rewrite from Go to Zig or this project. Thanks and have a great day.